Last class, all three of you made it. Good job. Um, Before we get into, I just want to do an overview for the final exam, and then I've printed off a practice final exam, and so that you'll have it. And also the formula sheet that you'll have for trig for the final exam. Okay? And so we didn't quite have time to finish the trig identities, and so due on Thursday, well, here we are. And a couple of notes, of course, our final exam is on Tuesday, December 9th. And I think it's in the 1 to 4 time slot. Let me just make sure. Although I haven't confirmed. Sometimes they change the room, but usually not the time or the day. 1 to 4 in E308. Now, that's just around the corner. So I won't be around tomorrow if you have questions, but you can always text or email me. But I will be around in meetings on Monday, but if you need me, then I can pop out and I can, and so I'll be around, I'll be on campus on Monday and Tuesday morning, of course. Don't be shy. Or available anytime by email or text. Usually I prefer text if you're kind of working on something, then it's kind of more immediate. So if you're struggling with something, then you can just text me 250-864-8386, which is on our Moodle page too. Don't call me because I won't answer. Because my ringer is never on, but also it's weird. Just don't answer. Okay. So trig identity, any questions about that before we do finish up some trig here? Trig identities, things like sine of theta is 1 over the cosecant of theta, right? We don't have time to talk about, what are some properties of cosecant, but just knowing that sine of theta can be rewritten as 1 over the cosecant of theta, or maybe more kind of interestingly, the cosecant of theta can be rewritten as 1 over sine theta, and so on and so forth, right? The secant of theta is 1 over cos of theta. A go-to one that we use is the tan of theta is the sine of theta over the cos of theta, right? That's kind of a heavy hitter. Okay. And also the cotangent of theta is the cos of theta over the sine of theta. Those are kind of the common ones. Now what you'll see on your formula sheet, which is I've got it pasted here. Okay. I've got just the top 2 rows for you on your formula sheet. Okay. And so you'll be given those, and then the Pythagorean identity is so important that I give it to you in a little box. Okay, cos squared plus sine squared is 1. We use that fact a lot. Okay. And for practice, you should be able to prove all of these guys that are in the pink section, let's call it. Okay. So this section is given on your formula sheet. Oops, let me do this. On the formula sheet. And for practice, you should be able to prove each of these. Now on this worksheet, I'm making you prove, I think, this one. Prove that they are the same. And then I picked one, and I can't remember which one on the practice final, but it'll be one of these on the final exam that you have to prove. So it's worthwhile kind of working through all of them, of course, so that you've seen them. But for trig identities, as you do more of them, you kind of pick up on some go-to moves. Okay. And so let's start with the first one. So use trig identities to write each expression in terms of a single trig identity or a constant. Okay. And so we've got tan theta cos theta. Okay. Like I said, if I see tan, then usually my go-to move is to say, well, what if I rewrite tan theta as sine theta over cos theta? That might be nice, right? And so I can rewrite this as sine theta over cos theta times cos theta. Now cos theta times 1 over cos theta is going to cancel, and now I'm left with one trig identity sine theta. And then I'm done. What if we have to do 1 minus... I need you to boost my numbers. That's the trig formula sheet that you'll have in practice. 1 minus cos squared over cos squared. Now, another heavy hitter that we have is the Pythagorean identity, right? So cos squared, and if I see a cos squared or a sine squared and a 1, then usually I start seeing, okay, well, could I manipulate this, right, into a number or into an identity, I should say. And there's kind of a lot of ways that you could do it. If you see a 1, what could you do? You could just replace the 1 with cos squared plus sine squared. Might be the easiest way to do it instead of kind of manipulating it. And so this is going to be replace the 1 with cos squared theta plus sine squared theta. Make it a little bit bigger before we try to make it smaller. Minus cos squared theta over cos squared theta.
We cannot just erase those two.
Which ones do you mean?
Like at the question?
Yeah. This here?
No.
It's okay. But here, the brackets aren't doing anything, so then I get cos squared theta minus cos squared theta, which is going to go away. But I'm left with sine squared theta over cos squared theta. Now, the thing about the sine squared and the cos squared, we can move it outside. The square on the sine and the cosine is really just a nicer way to read it, right? But technically, this is going to be the same as the sine theta over cos theta all squared. Now, sine theta cos theta, or sine theta over cos theta, is tan theta. So I can bump that out and say that's tan theta squared, or in a nicer way, tan squared theta, which means we've got it down to one trig identity, which is what we wanted. for C, when I see cos theta times cosecant theta, usually my instinct is to manipulate the cosecant theta. And so I'm going to scroll up and see cosecant theta is 1 over sine theta. So what if I replace that and I say cos theta times 1 over sine theta? And there's lots of different ways that you can manipulate these. The end goal is to get a single trig identity, right? And so there's usually lots of ways. But this becomes cos theta over sine theta. Let's rewrite it that way. And cos theta over sine theta feels like tan, but it's reverse, which is what makes it the cotangent, right? Cos theta over sine theta is the cotangent of theta. And now it's one identity, which is what we wanted.
Isn't it same as tangent -1 theta?
It is. So the cotangent is the inverse.
If I don't remember cotangent.
Then you can write tan inverse. That's okay. It's tricky because it's the reciprocal of tangent. It's not the inverse of gets.
I just
Yeah. You'll have these on your formula sheet. All right, these are on your formula sheet. Sine theta times the secant of theta over the tan of theta. My gut reaction is to try to manipulate the secant theta and see where that gets me. And then if that doesn't get me anywhere, then I'll do something to the tan theta, right? Because I can change the tan theta relatively easily. Did you get the trig worksheet last thing? Are you here on Tuesday? There. So much paper. So I'm going to start with the secant theta, which means I have sine theta times. The secant theta is 1 over cos theta. And then that's all over tan theta. Now sine theta times 1 over cos theta, I can rewrite as sine theta over cos theta. And then that's over tan theta. Now what's nice is tan theta over tan theta, right? Tan theta is sine theta over cos theta. And so then I get tan theta over tan theta, which is just 1, which is a constant, which was also one of our goals, right? One trig identity or a constant. Final thing we're going to do in this course is to prove one of those identities. Now, there's lots of different approaches. Some will be faster than others, right? But it doesn't matter, right? As long as you are only substituting the given identities, right? So on your formula sheet, you only have the top 2 rows, right? And this one, the Pythagorean identity. And so you're allowed to use those. And what you want to do is you want to manipulate usually just one of the sides until it turns into the other side. Okay? And kind of counterintuitively, I like to manipulate the more complex side because then there's more that you can kind of change, right? And so what I'm going to do, and like I said, there are lots of different ways, right? But you're going to manipulate one side until it looks like the other side, and then you've proven that they are the same. And so manipulate one side to look like the other. So my goal is to kind of morph this into a negative tan squared theta. Let's start with secant squared theta. Secant squared theta, can I rewrite that as something better? Well, secant theta is 1 over cos theta. So that means that secant squared theta is 1 over cos squared theta. So let's start there. So I get 1 minus 1 over cos squared theta. It's a good start. It's another thing I could do. Now, I know that tan theta and tan squared theta would be sine squared theta over cos squared theta. So that's kind of where I'm taking this, right? And so the next thing I could do, could force a common denominator, right? By multiplying this 1 by cos squared theta. Let's do that. 1 times cos squared theta over cos squared theta. That's just multiplying by 1. So it doesn't change anything. But now I can rewrite this. And I'm going to add a page here. And let's see if I can get some lines. So I get cos squared theta minus 1 divided by cos squared theta, right? I can combine them if I have a common denominator. Now we've seen this cos squared theta minus 1 or some version of it earlier, right? And so as soon as I see a 1, I see an opportunity to replace this 1 with the cos squared sine squared. So let's do that. So I get cos squared theta minus, and then you want to use brackets since you're subtracting, but then cos squared theta plus sine squared theta is equal to 1, right? And so I'm just replacing that 1 divided by cos squared theta. Once I expand these brackets, right, I get cos squared theta minus cos squared theta minus sine squared theta. Hey, things are shaping up. Divided by cos squared theta. Cos squared theta minus cos squared theta is going to go to 0. And what I'm left with is negative sine squared theta over cos squared theta, which is very exciting because sine squared theta over cos squared theta is tan squared theta. And then I have the negative out front. So I get negative tan squared theta. Whee! And then you've proven that they are the same. So like I said, I will make you prove one of these, I don't know how many, 1, 2, 3, 4, 5, 6, 7, 8 identities on the final exam, but it will be one of these. Okay, so we just did the one, and then there's another one on your practice. Okay, and oh, that's what I was going to say. I will post a mom online practice for the final as well, but I don't think that there are any proof problems on there, right? So there won't be a proof in the mom questions because that's really hard to do electronically, right? I'll see if I can find one, but I don't think so. So just try all of these, make sure you kind of learn all the tricks, and then we'll be good to go.
We can just choose any way to prove it, right?
Mm-hmm. As long as what you're substituting is true, right? And only using those given functions, then you're good to go.
Because I changed the tan square data to the second square data -1. The last one.
Which one?
This question.
Yeah.
I changed tan square
Yeah.
data into the sec square data -1. Because there's a 1 plus tan square data.
Oh, but you can only use these ones because they're the ones that you'll have on your formula sheet.
Oh.
Otherwise, yeah, you could do that if you had them. But yeah, I decided to only give you those because otherwise it's too easy. Too easy. And just like that. Did it. So, it's obviously the end of material. There were just a couple of things, and I don't have a lot lined up for today. And it sounds like there's a communications paper happening. So I'll just go through it. But you have the trig formula sheet. I don't know why there wasn't a trig page earlier, but these 2 pages, which you have a printout of, is what you will have for the final exam for your trig, right? And so here are those identities that we were working with, and of course the Pythagorean identity. Inverses, right? We focus on the inverse sine and cosine, but the tangent's on there for completeness. And then the transformations of sine and cosine, right? Things like the amplitude, the period, and the midline, which we talked about last day. And then just so that the unit circle could be nice and big. Now I'm wondering how it printed. Oh, it printed better, okay. Because it was so faint last day. But I tried to make it as big as possible, so I put it on the last page just so that you could have it nice and big. Okay. Hey, why is it blank?
Are we getting answer sheet this one?
To the practice? Yeah, I'll post it. Yeah. I don't know why it's not. There it is. So just like test 2, I didn't have it for test 1, but I have put together the core concepts that we introduced for test 1, right? And so I'm obviously not going to read all these. Okay? But before I post the notes, because I didn't do a run through, but you could use the practice final that I gave you to check out the approximate grades. But what I'll do before posting is I'll put kind of approximate marks just so you know kind of for each section what to expect. Gets kind of confusing because the distance equation and the equation of a circle, they were introduced in 1.1, but then we didn't really use them until 5.1. And so I won't use those grades as part of the 1.1 marks. I'll say here C 5.1 and C 5.1. But here's an outline of all the things that we talked about in each section, all the things I'm expecting you to be able to do. Then test 2 core concepts. And of course, trigonometry core concepts. The Pythagorean theorem, the distance formula. So this is where kind of calculating the distance between 2 points and finding the equation of a circle, right? Those are going to come into play. Right, the equation of a circle given the center and the radius or given a graph. The intersections of a line and a circle, right? That's something like the ant problem, which I really enjoy, and there will be an ant problem on the final exam, and there is one in the practice. Because I think it's a cute way of testing that. And then we talked about just angles and terminology and coterminal angles and the arc length. Sine and cosine as points on a circle. SOHCAHTOA, of course, which I have not put on your formula sheet because I feel like you should probably know it. And it's just a mnemonic anyways. Solve for cosine, sine, and an angle. Use the Pythagorean identity to solve problems. Solve word problems using trig. And then here from those trig notes that we had last day, the trig worksheet, right? We introduced the unit circle, quadrants of a circle, cast for positive values of sine and cosine and tangent, inverses, graphs of inverses, using inverse trig functions to solve problems, which I sneakily introduced. Where is it? Sneakily introduced here, and an angle. Then you have to use the inverse trig functions. Intersections of a circle and a line, right? Again, we had a couple of different examples. Right? But you've got a line that you need to build, and you have a circle, and you have to find the intersections. And in the ant problem, it takes it one step further, right? And you find the distance between those 2 points on a circle. Transformations, amplitude, period, and midline. Now that's on your formula sheet, right? So if I give you a function, you need to be able to map that back to the amplitude, period, and midline. Solve a word problem involving a transformed sine or cosine function. We had a couple, most notably the tide question, where the boat needs a depth of 9 feet, right? And so when can it dock? Right? And then use trig identities to write an expression as a single trig identity or a constant, which we just did, and then prove trig identities. So it'll be one of those ones that we saw. And then I give you a practice final. Right? And so what I would do is I would encourage you to do is study for the final, right? And maybe try the mom questions that I'll post once we're done here. And then when you feel ready, right, then try the practice final and then check against my solutions that I'll post. Okay? And so, and then you'll have a pretty good idea of kind of where you're at, right? And then fill in the gaps from there. But crazy. I knew I didn't have a lot, but are there any questions? So, you haven't really had a chance to flip through the practice final, but are there any questions about the practice final? Not yet. Like I said, I'm available Monday, Tuesday morning, or you can text or email me anytime. And with that, I release you. If you have any questions, let me know. Otherwise, congratulations, you did it. I'll see you on Tuesday. Nothing else. And I'll stop this.